In this video, we are going to solve NEET 2017 question paper. The first question reads, two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless spring. So see the difference between a string and a spring here. The magnitude of acceleration of A and B immediately after the string is cut are respectively. So it says immediately after the string is cut. So the difference between a string and a spring is when you cut a string, the changes are immediate, whereas the spring will retain its force. Spring force does not change immediately after cutting the string. So when we cut the string, the lower block will start falling with G because it is unsupported. Whereas on the upper block, which has mass 3m, its weight 3 mg act downward. The string is cut, so no force by the string here, and the spring will keep on exerting the same force which it was exerting before, that is 4 mg. The spring was exerting force equal to weight of the two blocks. Even after cutting the string, it will keep on exerting 4 mg immediately after. So the net force here on the block is in upward direction of value mg, and therefore the acceleration of the block will be equal to mg divided by 3m, which is equal to g by 3. So the second option, g by 3 and g is correct. G by 3 for the block A and g for block B. In fifth question, it says a capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. So we have a capacitor which is charged, say charged through voltage V. So we will have charge CV here and minus CV. Now it is connected in parallel to an uncharged, say 0 charge capacitor, but identical. So the capacitance is C, the upper also has capacitance C. Now it says the total electrostatic energy of the resulting system. So initially it had energy as half CV square. Now there will be some charge sharing, and as we know that the charge sharing causes charge to distribute on both the capacitors, and it is a spontaneous process. And as we know, all spontaneous processes leads to decrease of energy. Here potential energy. So the final potential energy definitely will be lesser than initial potential energy. Now let us examine the options. The first says it increases by factor 4, which is incorrect. The third says it remains the same, which is again incorrect. And fourth says it increases by factor of 2, so it is incorrect, and hence we have the second option, correct option. So in exams like NEET, where you have insufficient time for solving all the questions, you should always eye the options. The options in few questions are always like this, that you obtain the correct answer by striking out the wrong ones, or you have some clue in the options itself, say like dimension, dimensional clue or something like that, from where you can judge the correct answer even without solving the question. Anyway, for the complete solution, what we can do is, for finding final energy, see the charge CV is distributed now on both the capacitors. So the equivalent capacitance C and C we can take as 2C, and the charge will remain same because the second capacitor was initially uncharged. Now the final energy of this combination or the equivalent of the combination is CV square, that is the charge square, upon 2C. So 2 into 2C. Now notice the difference. Here you have half, here also you have half, but you have one additional 2. So it decreases by factor of 2. In question 6, it says two rods A and B of different materials are welded together as shown in figure. Say here you have temperature T1, here you have T2, and the rods are put here in parallel. So the rods A and B are put in parallel. They have conductivities K1 and K2. The thermal conductivity of the composite rod will be. So by looking at the question, what things come in mind is resistance R is equal to L upon Ka. Remember, thermal resistance R is L upon Ka. And the second thing which comes in mind is that the two rods are connected in parallel. So 1 by R is equal to 1 by R1 plus 1 by R2. So 1 by R will be proportional to K. So if you replace 1 by R with K, then what relation you have? We have relation K is equal to K1 plus K2 by 2. The 2 appears here because the resistance, the composite resistance will have twice the area of the individual rods. So in place of area you will have 2 in case of R, whereas you will have A and A in case of R1 and R2. So K is K1 plus K2. So remember this proportionality. Wherever you get this proportionality, that is, the formula is inversely related, but resistance was inversely related to K. So K ultimately comes in numerator. So mainly you have these kind of options. The other case could have been, had the K been in denominator, you would have got 2K1 K2 by K1 plus K2. So obviously that was not any of the options. So the correct option is K1 plus K2 by 2, which we could have directly marked. Bulk modulus. In question 8, it says the bulk modulus of a spherical object is B. It is subject to uniform pressure P. Then the fractional decrease in radius. So as we know that stress and strain have relation between them. The bulk stress delta P is equal to minus B delta V by V. So here we will take the modulus, that is mod of delta P is equal to B and mod of delta V. We are not bothered about sign because we know that with increase in pressure the volume will decrease, and they are asking decrease in volume. So whatever answer will come positive. So in place of pressure we have P is equal to B and delta V by V. But they are asking fractional decrease in radius. The volume of a sphere is proportional to RQ. Hence delta V by V will be equal to 3 times delta R by R. This expression we obtain using binomial. Hence pressure P is equal to bulk modulus into 3 delta R by R, or delta R by R is equal to P by 3B. So P by 3B. In question 9, it says a physical quantity of dimension of length that can be formed out of C, G, E square by 4 pi epsilon naught, where C is speed of light, G is gravitational constant, and E is charge. So see, the general method says that let the physical quantity P be proportional to C power A, G power B, and the third quantity E square by 4 pi epsilon naught power D. Writing their dimension, equating them, we can have their equations, but it is quite time consuming. So look at the form or the quantities, they are interrelated to each other. Like force is equal to G m square by r square. Also force is equal to charge square by 4 pi epsilon naught and r square. So their combination, that is combination of E square by 4 pi epsilon naught and G. We can see that the G is equal to Fr square by m square, and when this is multiplied to E square by 4 pi epsilon naught, which is Fr square. So what we see here is G into E square by 4 pi epsilon naught. Why we have chosen the product? Because in three options we have same form. So most likely any of the three forms could be the answer. But if this form does not satisfy, then obviously the other which has G in denominator will satisfy. So here we have F square R4 upon M square. So force has dimension of mass, force is squared, so the mass gets cancelled here. Because length is asked, we should not have mass here. But we have a R4. So we need speed of light in denominator here. Because if we will have speed of light in numerator, like in the second option, then the power of R will further increase. And in denominator, we should have square of speed, because then only the power of R will reduce. And therefore the first option is correct, because in the third option we have this G in denominator, whereas in fourth option we have R power 4 in numerator, and if it is divided by C, then the power of R will become 3, which in no way is going to give us length. So by looking at the options, first option is correct option. Question number 15. Two cars moving in opposite direction with speed 22 meter per second and 16.5 meter per second. The driver of the first car blows a horn having frequency 400 Hz. So F0 is 400 Hz. It is case of Doppler effect. The frequency heard by the driver of the second car is. So the frequency from Doppler's effect is V, velocity of sound, plus minus velocity of observer upon V minus plus velocity of source into F0. So we have this common formula for frequency using Doppler's effect. Now we will place data in this formula. So the frequency F is equal to velocity is given as 340. So 340, the observer is approaching the source, so the frequency will increase and we will have positive sign plus 16.5 divided by 340, and source is approaching the observer, so this will also lead to increase in frequency. But since source velocity is in denominator, so it will be accompanied by negative sign. So the source velocity, which is 22, so 22 will place here, and frequency is 400. The value of frequency becomes 356.5 upon 340 minus 22 is 318 into 400. So this value will come more than 400. Now see, the values which are less than 400 will automatically get cancelled, and more than 400 we have two values, but see here that 318 when divides 356.5, the value will be nearly 1.1. Say approximately, you can figure it out, you do not need to calculate it. So 400 into 1.1 comes closer to 440, and obviously we will have answer as 448. In question number 16, a 250 turn rectangular coil, a coil having large number of turns, 250, of length 2.1 centimeter and width 1.25, carries a current 85 microampere subject to a magnetic field of a strength 0.85 Tesla. Work done for rotating the coil by 180 degree against the torque is. So work done by external agent is change in potential energy. Obviously all the options have positive sign, so you need not worry about the sign whether it is positive or negative. Just concentrate on the value of change in potential energy is equal to M into B minus M into B, because if you have positive potential energy to one side, then we will have negative potential energy when it is turned by 180 degree. So it is 2 MB, and magnetic moment as we know is equal to NIA, and it is multiplied by magnetic field. So substituting the values to N, which is 250, current which is 85 microampere. So we are not bothered about the power of 10. We will simply see the numeric value because the options are very wide. Multiplied by area. For area we have length equals to 2.1 centimeter and width is 1.25 centimeter. Multiplied by the strength of magnetic field, which is 0.85 Tesla. This is 2. This is approximately 2. Multiplied by 250, it gives 1000. So retain the 1, remove the zeros. So 1000 multiplied by 85 is 85,000. So retain 85 or 8.5. Multiplied by another 8.5. So it will be more than 64, and multiplied by 1.25 will lead you to 9.1 microjoule. So without proper actual calculation, you should arrive upon the answers because time permitted for questions is very small. It says de Broglie wavelength of a neutron. So as we know, de Broglie wavelength has formula h by p, where p is momentum, and it says temperature. As we know, neutron is neutral species, so the speed which it will have will be like monoatomic gases equal to under root 3 kT by m. See, if m is mass of an individual molecule, then we will use K, Boltzmann's constant. If m is mass of 1 mole of the gas or the species, then we will use gas constant. That is, for molar mass we will use gas constant, for individual molecule we will use Boltzmann's constant. So here it is case of individual molecule, so we will use Boltzmann's constant. So lambda therefore is equal to h by p, where p is m under root 3 kT by m, which on solving comes as h by under root 3 m kT. So third option. In question number 23, it reads, a thermodynamic process are indicated in the following diagram. So these are isotherms, that is the curves are at same temperature. Now in column 1, process 1. So process 1 is a vertical line. This vertical axis is pressure and this is volume. Then the vertical line indicates that it is constant volume. So 1 corresponds to isochoric, that is C. So here the process 1 corresponds to C. So the incorrect ones are A and D. Now in Q the options differ. So let us check for Q. So Q is process 2 and process 2 is also a curve. Therefore it cannot be isobaric and it cannot even be isothermal. Therefore we will rule out option 3rd, because option 3rd says the process 2 to be isothermal, which is not to be. Hence the option B is correct. A spring of force constant K is cut into lengths of ratio 1:2:3. The lengths are in ratio 1:2:3. That means adding these ratios we have 6. So the smallest part will be 1/6 in length. Then springs have a relation that the spring constant into length is constant. That is, when the length is decreased, spring constant increases, and when length is increased, spring constant will decrease. A shorter spring will have higher spring constant. So here the smallest part is 1/6 in length, so its spring constant will become 6K. The second part, which has ratio 2, is double in length, therefore it will have a spring constant half of the first part, so it will have 3K. The third section is thrice in length of the smallest section, so it will have a spring constant of 2K. Now they are connected in parallel. As we know, when springs are connected in parallel, then equivalent spring constant is sum of the individual spring constants. So we have 6K plus 3K plus 2K. So it is 11K. Hence the ratio 1:11 is correct answer. A Carnot engine having efficiency of 1/10 as heat engine is used as a refrigerator. So in a Carnot engine, efficiency is given by 1 minus T2 by T1. So the efficiency which is given as 1/10 is 1 minus T2 by T1. So from here T2 by T1 will be equal to 9/10. Now in case of refrigerator, the coefficient of performance is heat rejected by work done, which in case of Carnot refrigerator is T2 divided by T1 minus T2, where T2 is the lower temperature. So Q2 by work done, the work done here is 10 joule, is T2. So bring this T2 in denominator, we will have 1 divided by T1 by T2 minus 1. So Q2 by 10 is 1 by T2 by T1 is 9/10. So T1 by T2 will be 10/9 minus 1, or Q2 by 10 is 9 divided by 1, or Q2 is 90 joule. In question number 32, it says an arrangement of 3 parallel straight wires. So these are the parallel straight wires placed perpendicular to plane of paper, carrying current I along same direction. They carry current I outwards, that is in same direction. Magnitude of force per unit length on the middle wire B is given by. So this wire will attract this wire this side and this will attract it this side. Let the force per unit length be F, then this will also exert force per unit length as F. So their resultant will be F root 2. The force per unit length is given by mu naught I square by 2 pi d. Multiply it with root 2 or the net force will be mu naught I square by 2 pi d and root 2. So what we have here is mu naught I square by root 2 pi d. Fourth option as correct. In question number 34, it says the ratio of resolving power of an optical microscope for two wavelengths 4000 and 6000. Resolving power is inversely proportional to 1 by lambda, because from the diffraction pattern we see that the diffraction pattern has central maxima of width 2d lambda by d. Wider will be the diffraction pattern, then lesser will be the resolving power. So resolving power is inversely proportional to lambda. So clearly the ratio of resolving power 1 by resolving power 2 is lambda 2 by lambda 1, that is 6000 angstrom by 4000 angstrom. So the ratio is 3 by 2. So the third option is correct option. In question number 40, two disks of same moment of inertia rotating about their regular axis passing through center and perpendicular to plane of disk with angular velocities omega and omega 2. So when they are brought in contact, finally they will rotate with a common omega. So this case is similar to a collision between two balls, and in such cases we can use a case similar to reduced mass, or in such cases loss of energy can be written as half I1 I2 by I1 plus I2 into omega relative whole square. The reduced mass concept videos can be seen on this channel to understand these cases. So substituting here the values, loss of energy is half, since both the moment of inertias are same, so I square by 2i, and relative angular velocity is omega 1 minus omega 2. So omega 1 minus omega 2 squared. So what we have here is 1 by 4 omega 1 minus omega 2 whole square. So second option is correct. In large number of cases which have been frequently asked in AIPMT or NEET examinations, we can use this concept of reduced mass, which is primarily used for collision but can be extended for finding loss of energy in case of disks, in case of combination of capacitors, in case of inductors, and so on. In question number 43, it says in an electromagnetic wave in free space, the root mean square value of electric field is 6 volt per meter. The peak value of magnetic field is. So in an electromagnetic wave, E RMS by B RMS is equal to speed of light. So B RMS will be E RMS upon C. And now the peak value of magnetic field B0 will be √2 times BRMS. That is the relation between RMS and peak value. So is √2 times ERMS, which has value 6, upon C, which has value 3 into 10 raised to power 8. So it becomes 2 √2. 2 √2 has value 2.83. None of the option has this coefficient, so B is correct option. If theta 1 and theta 2 are apparent angles of dip observed in two vertical planes at right angle to each other, then the true angle of dip is given by. So apparent angles of dip, when the BH, the horizontal component, is taken in a particular plane other than the magnetic meridian, then it becomes BH cos, say if this angle is phi, so it becomes BH cos phi. The vertical magnetic field remains same. Angle of dip is the net angle which is formed. So in this new plane we have tan delta dash, the apparent angle of dip, delta dash, as BV divided by BH cos phi, whereas true angle of dip, tan delta, is BV divided by BH. In two perpendicular planes, so if in one of the planes we have component BH cos phi, then in its perpendicular plane tan delta double dash will be equal to BV by BH cos 90 minus phi, which is sin phi. That is BV by BH sin phi. We already know that in perpendicular planes, if one of the component is cos, then other will be sin. So what we see here is the cos phi and sin phi comes in denominator. Now to get rid of cos and sin, we must take reciprocal and square them, because cos square phi plus sin square phi will be equal to 1. Hence, in place of cos square phi, the proportionality will give us 1 by tan square delta dash plus 1 by tan square delta double dash, and obviously this will be equal to 1 by tan square delta. In this question, delta has been replaced, this has replaced by theta 1, this is theta 2 and this is theta. So obviously when they reach in numerator, the relation is cot square theta 1 plus cot square theta 2 is equal to cot square theta. So the correct option is first. Thank you.